Hello guys, in this video we are going to talk of the problems from Div2 Starters 75. So I'll be talking of the first four problems, that is 3 power of 2, prefix ones, equal Hamming distances and Schiff's favorite function. So without further delay, let's get started. So the very first problem is 3 power of 2. The problem states that Schiff is given a number in form of a binary representation is having a length n. We have to determine if it's possible that this number can be represented by exactly 3 non-negative powers of 2. By non-negative, they mean that we cannot take 2 to power minus 1, that is basically 1 by 2, so we can't do that. So the powers have to be 0 or positive. So after that, they have given the constraints that are pretty lenient. So they'll be providing us with the number n and a string of length n. Now we need to tell them that if it's possible for us to represent that particular number that is denoted by this particular string in binary notation, if it's possible for us to represent it as a sum of powers of 2, or in particular as a sum of 3 powers of 2 in total. So for example, can we represent 1 by 3 powers of 2? No, we can't, so we'll print a no over there. Over here they have given us a value 1001 that corresponds to 9, and can we print 9 as 3 powers of 2? Yes, we can. So we can write 9 as 2 to the power 2 plus 2 to the power 2 plus 2 to the power 0. So that would be 4 plus 4 plus 1, that is equal to 9. So we can do that. Then they have given us another example. So over here the value is okay, 1 plus 2, 4, 8 and 16. 8 and 16 is basically 24, 24 and 25. So can we represent that? Yes, we can. So this is the way of representing it. Then they have given another example. Over here there's a bigger value, but we can't represent it as a power of 3, so we'll print no. So we don't have to tell them that how we are going to represent it. We simply have to print a yes or no corresponding to the question. So let's try to understand the intuition behind it. So when I'm representing a number in the binary format, so I have some ones and some zeros, right? Now let's say the number of ones are exactly equal to 3, right? In that case, the number of ones actually correspond to some power of 2, right? So over here, this is basically 2 to the power 0, this is basically 2 to the power 1, this is 2 to the power 3, and this was 2 to the power 2, which is actually 0. Cool. So this can actually be represented as 2 to the power 0 plus 2 to the power 1 plus 2 to the power 3, right? So the first case is if the number of ones are equal to 3, then yes, I can do that. Second case is, let's say the number of ones are equal to 2, then can I do that? Yes, that's also possible. So how I'll be doing that is, let's say this is the number given to me, right? So I'll take this particular number as it is. So I'll write it as 2 to the power 0, right? This is nothing, but over here I have only have one left, but I need to provide it with two values, right? So what I'll do is, instead of writing it as 2 to the power 2, I'll write 2 to 2 to the power 3. Instead of writing it as 2 to the power 3, I'll write it as 2 to the power 2 plus 2 to the power 2. So in that way I'll be able to do it. What if my n is equal to 1, or the number of set bits are actually equal to 1? Let's write it as set bits are equal to 1. In that case, what I can do? Even in that case I can do it. So let's say this is the number, it has only one set bit. I can write it as okay, so this is basically 2 to the power 3, right? This is 2 to the power 2, 2 to the power 1, 2 to the power 0. I can write it as 2 to the power 2 plus 2 to the power 2, that is obvious. I can further write 2 to the power 2 as 2 to the power 1 and plus 2 to the power 1. So in total 2 to the power 3 can be written as 2 to the power 2 plus 2 to the power 1 plus 2 to the power 1. I hope this is making sense. Now there are some edge cases that we actually need to check. So if the set bits are greater than 1, or greater than, sorry, set bits are greater than 3, then the answer cannot exist. So in that case I'll be printing no. If the set bits are equal to 1 and the value also, let's say, is less than, or the number of bits are actually less than 2, right? So if in that case these are the possible values I'll be having. In this case I cannot represent it as a power of 2, because let's say 10 is the thing I'm having. Then if I write 2 to the power 0 plus 2 to the power 0 plus 2 to the power 0, then it's not valid. This would sum up to 3. I actually need 2. If I write 2 to the power 0 plus 2 to the power 0, so this actually is a minimum thing. So let's understand it that way. So 3 is the minimum value I'm gonna get. if I'm just adding 2 to the power 0, right? So if my number is less than 3, then the answer does not exist. That's obvious. So I'll just simply check if the length of the string is less than 2, then the answer does not exist. Then the answer would be no, right? Else in every case the answer is going to be yes. So let's look at the code. So the code over here is fairly simple. So if the number of counts, so I've just taken the number count of ones. So if the count is equal to 3, then the answer exists. If the count is greater than 3, then the answer does not exist. If the answer count is equal to 2, then also the answer exists. However, if the number of the length of the string is greater than 2, and the number of and the count of ones is equal to 1 even, then also the answer exists, else the answer does not exist. So this was fairly simple, just a few edge cases that we need to do test. Let's move on to the next problem. The next problem is prefix ones. The problem states that chef has a binary string s of length n. Chef can perform the following operations on the string. He can choose any substring of s, remove the chosen substring from s, concatenate the remaining parts of the string s obtained after after removing the substring. So we have to find the length of the longest prefix having all ones, which you can achieve by performing the above operations at most ones. So these three operations are a set of or these three things actually constitute a single operation. So this is what we can perform, and we can do it at most ones. So either we'll do it as 0 times, or we can do it at max ones. Then they have given the input format, so that's also fairly simple. They'll just be providing us with the length of the string and the string itself. The solution needs to be in an order of n or order of n log n solution. That's like correctly visible over here itself, because the n square would give a TLE. Then they have given some examples. So for example, over here we have a string 1010. Now if we remove this particular 0 or this particular substring, we can call it a substring as well. So the string will be left with would be 110. Now in the string 110, two ones are actually present to the leftmost side, right? Or consecutive number of ones at the leftmost location are actually 2. So we'll print a 2 over here. In this case, in the second string, let's say we remove this 0 from here, then we'll be having a string 11011. In this case also, the number of ones or consecutive number of ones from the left hand side is actually 2. So we'll again print a 2 over here. What about this string? Now in this string, let's say I'll remove this particular thing or this entire thing. In that case also I have 3 ones remaining, so I'll print 3 over here. So that's it for the question. Now let's try to understand the intuition for it, or how to solve it. Cool. Okay, so over here what I can say is that there could be two cases, right? Now before I discuss the two cases, one simple thing to observe is that if I am having a 0 at the first location, right, in that case I'm left with no choice, but I'll definitely have to remove the substring I'm gonna remove definitely has to have a left index over here itself, right? Only then it would make sense. So if the first index is 0, then the substring I'm gonna remove is gonna have the left like index over here itself. The right index might vary, that we can decide further, but the left is gonna be over here for sure. What if it's actually 1? What would happen in that case? In that case, what I can do is that I can remove any substring from the middle of it, right? Such that after removing that particular substring, now that particular that substring can actually start from here. Okay, so that substring can actually start from left hand side itself, or that could start from some other element as well, right? Because we are having 1 at the initial location, so it's not mandatory for us to start the substring or the substring to be removed from the very left hand side or from the index 0 itself. So this is the first thing. Now what I can do, so this is a fairly simple question. I think I can directly go through the code itself, so even that would be understandable. So firstly I'm taking variables mx, res and mx store. Mx store is actually not required, this I used for some testing, so let's remove that. Cool. So now what I'm doing is I'm calculating the number of ones, or in other terms, let's say I'm calculating how many contiguous ones are there, right? I'll be storing the maximum number of contiguous ones. So this is a simple code. If I'm getting a 1, then I'm incrementing my count and I'm storing the maximum number of ones over here. If I'm getting a 0, then I'm setting my c to 0 or the count to 0. That's it. Now the mx would now be available, or it's the pocket which actually contain maximum number of ones or the maximum number of ones in a certain pocket is denoted by mx. I'll assign this value to this. Now over here I'm making a check that if my s0 is equal to 0 itself, that means, so if this is the case, that would mean that I'll definitely have to remove a string from the left hand side itself, right? In that case, whatever value was there in my result would be the final value. So I'll print that over here itself. Cool enough. After that, I'll check that if the leftmost element was actually 1, in that case it is up to me that I can select any value for that matter, right? So if okay, so if it was if the first value was 1, then I can select any other value from the middle of the array itself. So that's what I'm gonna do over here. So what I'm gonna say is that firstly start incrementing I from the left hand side till the time you are seeing all ones, right? So till the time you are seeing all ones, keep incrementing it. As soon as you see a 0 or you are out of index, then quit the loop and then store the initial number of ones you are having in another variable. So ini is the variable which is actually now storing that value. After that, I'll start another loop. So in this loop, I'll start from this particular index itself. So I'm not resetting the value of I. The value of I still is the value that I am having over here. So I'm not resetting it. Now I'll start to calculate that after this particular index that I already attained. So after all the i's starting at the left hand side were done. So from that point onwards, do I have a contiguous pocket of 1? If I have that, I'll try to get the value of that particular pocket. So when I say a pocket, I mean a contiguous subsegment that is having all ones. So this is the simple way. This is a pretty standard way of calculating pockets, I'll say. If you have any doubts, you can comment down below. I'll try to explain that this also. So now I'll try to check that if I'm having contiguous pockets of ones, if I have that, then I'll keep storing that particular value in C, or I'll keep incrementing my C till that I'm having ones. And also I'll update my result to be max of result, either the initial value it's having or the number of ones I'm having in the first pocket itself plus the current pocket. So there was a first pocket. Okay, let me just explain this a bit more. So this is the case, then you're having some ones. So one or more ones were here, then you had some zeros, let's say, then you can have ones like this and then zeros, then can have some ones. So basically this is already stored in ini, the variable ini. This is already stored over here and my I was over here then, right? So I'm moving to the right now, and meanwhile I'm now checking that which pocket has how many number of ones. So this number would actually be stored in C, and when I'm incrementing my C, so I'm also incrementing my result as result is equal to max of result plus. So what if I say that I want to select this pocket as a second pocket, then I technically mean that I'll be removing these set of zeros, right? So I'll say result plus C. Now let's say instead of these ones, I wanted to select these ones. So in that, if I do that, then I technically mean that I'll be removing this entire substring. Cool. Now if I remove this entire substring, the substring I would be left with it would be 1111. That would be my initial, and this particular ones, right? So that's exactly what I'm doing over here. I think that's understandable. That's pretty easy to understand even. Also, once I'm done with that, I would be having the value in the result variable. So I'll be directly printing that. Cool. So this also was simple. Let's move on to the next one. This one is not tough. Definitely not tough. It's kind of easy. But there's a small catch over here. If you are able to do that, then it's pretty easy. So it's just like it's just regarding combinatorics. If you don't have an idea about combinatorics, make sure to watch a video. I already have a video on this channel which talks about combinatorics in detail. I'll try to put the link in the description section. Cool. So the problem states that chef is given two binary strings A and B having a length n. Chef wants to find the number of binary strings C of length n such that HAC. Now H over here is basically the Hamming distance of A comma C is equal to the Hamming distance of B comma C, right? Now they have given the like what H is, so I have already explained that. And since the okay, so we have to tell all the possible strings C such that this equation or this equality is satisfied. Cool. At the end we have to tell the number of strings, so or number of strings C. Since the answer can be large, we have to print the value modulus of 10 to power 9 plus 7. The input format is then provided, so they'll be giving integer t, then they'll be giving integer n, that would be the length of the string a and b. Then they'll be providing us the string a and b itself. After that, the single variable that we have to output is actually the number of strings c that can exist. Cool. So this question doesn't require a lot of complicated DSA, just a simple logic. Cool. Let's get started with this. Okay, so let's say this is the string I'm having. So this is my string a, right, and this is the string v. Let's say, just taking a random string for the moment. So what would happen is that since these two this is a and this is b, right? Okay, so let's just improve the way of writing it. Let's say this is, pardon me, 10101, right? This is b 11001, right? And I want a c. Now since c is the Hamming distance, and Hamming distance basically means the number of bits that are different, so the number of bits that are different in a and c should be equal to the number of bits that are different in b and c. I hope that makes sense. So if a, or the bit at the index 0 of a and b is actually same, then I can keep any value at c, because let's say if I keep 1 over here, then in that case it's similar to the value that is present in a and b, and my Hamming distance is going to be incremented by 0, so that wouldn't make any difference. If I keep a 0 over here, then it's different to both a and b. In that case, my Hamming distance would be incremented by 1 in both the scenarios. So it would be incremented for h a comma c and h b comma c as well, right? So even that wouldn't change my Hamming distance overall, because I'm adding 1 to both of them. So the difference between difference actually remains 0. So whenever I'll be having the same values, in that case I can say that both of the values are applicable. So I can either have zeros or I can have ones. It wouldn't matter. So over here I'll say it won't matter. Now over here for a I have 0, for b I have 1. Now let's say for c, if I keep 0, then HAB is not going to be effective. If HAC is not going to be affected, but HBC is going to be affected, because HBC would now be incremented by 1, right? In this case I won't do anything right now. I'll just keep a count of the number of such indices. So the count is currently 1, right? So I calculated this. Now over here also the indices are different, or the values are different, so I'll increment my count. Over here I incremented it, right? Over here now the count is same, so I'll say that okay, over here also I can keep any of them. So my result was initially 2, because this is something I already checked. Now I'll multiply it by 2, because for this also I can have either 0 or 1, so I'll multiply it by 2. Now coming to the last index, over here I'll say that okay, so I have a 1, right? I also have a 1 over here, so the numbers are same, so I can have either zeros or 1, so I'll also multiply it by 2. So right now my result is 8. Also the indices that were actually different are actually 2, right? Cool. So if you remember, now setting a current any value would increment a by 1, right? A by 1, or would, sorry, let's say if I assign any value 0 or 1, that would either increment h of AC by 1, or that would increment h of BC by 1, right? That's already known. So what I need to do if I want to have HAC equal to HBC, H over here means the Hamming distance, I hope at least you know that. So if I want this, what I can say is that for one of the bits, over here I am having 2 bits, right? So for one of the bits, if I select 1, or if I select such a value, okay, give me a second, yeah, okay, so if I select such a value that HAC increases by 1, then for the other bit I have to select a value such that HBC is increased by 1. That is fairly simple. I'll be able to do that, right? Now how do we generalize it? Over here there were only 2 bits, so I said that okay, we can do that. How can we generalize it? So let's say we are having n bits where or let's say we are having x bits where the value was different in A and C, right? So for those x bit, I can say that I want to divide them into 2 pairs each, or in other words, I want to have x by 2 pairs in total, right? When I say a pair, so that would be dependent pairs. So when I'll be let's say the pair is ai bi, so for each of these pairs, what I'll be doing is that I'll keep a check if I keep the value of ai as a 1, right? Or I keep the value of ai such that h of a comma c, right, is incremented by 1. In that case, the value of b should have been h of such that the h of bc is incremented by 1, right? So that is something I'm gonna do. Cool. So that's the entire thing I'm gonna do, and the implementation is fairly simple. So initially I'm taking the two strings a and b. Then if the value of a and b is equal, then I'm like multiplying my result by 2. Else I'm incrementing a count variable by 1 itself. After that I'll check. So now there's one edge case. So now if the number of count or the number of bits that are different are actually odd, in that case my answer cannot exist, because what would happen is if the number of bits are actually odd, so in that case, okay, so let's come over here. So let's say these are 3 bits were there that were actually odd. So like one of them can increment h of ac, one of them can decrement h of one of them can increment h of bc. What would the other one do? So it's gonna increment or decrement something at least, right? It cannot be the case that it increment or decrements nothing or increments nothing, right? So when it will increment h of ac, then h of ac would become greater than h of bc. Otherwise, if it increments h of bc, then h of bc becomes greater than h of ac. So this is gonna spoil my equality. So I just want a way so as to divide the number of bits into two sets, or two proper set, two equal sets, I can say, right? So if I'm having odd number, I'll not be able to do that. So in that case, I'll simply print a no, or print a 0 over here, because 0 strings are that can satisfy the constraint. If my count is greater than 0, in that case I'll try to find the number of ways I can select like count by 2, or count over here is actually the number of bits that were different in a and b. So in that case, I'll have to divide them into 2 pairs each, right? So I'll select the number of ways of doing that. I'll multiply the number of ways by result, and I'll print out the value. Cool. So fairly simple. So one thing I actually do is that I have this pre-written code. So whenever I want to calculate NCR and stuff, I already have this snippet saved, so I don't have to like code them again and again. You too can actually save these things up so that whenever you need them, it's just a click away. Cool guys. So with that, let's move on to the next and the last question. So the problem states that there are two functions, fx and gx. These are the values, right? And then you will be giving L and R, and you have to select a number x that is between L and between R, such that f of x plus g of x is maximized. Cool. That's it. That's what the question says. Now let me try to give you some insights over here. Although you can do it without that also, but let me give you some insights that actually helps to formulate the solution. So over here they are saying that if x is equal to 1, then the value is 0. So this is the base case. If x is even, right, then I'll be adding 1 into it, and I'll be returning the value of x, f of x by 2. So from here you can see that let's try to think in binary notation format. So if x is even, that means that the leftmost value or the rightmost value I'm having, or the least significant bit, is actually 0, right? Only then it would be even. So as soon as we divide it by 2, that is equivalent to right shifting it by 1. As soon as we do that, that 0 would be gone. Now once that 0 is gone, it is actually leaving us with a value 1. On the other hand, if it was odd, that would mean that least significant bit was actually 1, and when we right shift it, that 1 would be gone, but that's not leaving us with anything, right? So technically f of x is basically the number of zeros that you will be having in the binary notation of any number, right? Let me give you an example. I want to complete this video soon, but let's just give you an example. Let's say this is the number you are having, right? So this is basically 9. So when you will do, so 9 is odd, right, because it is having 1 at the last location. So its value would be given by f of 4. 9 divided by 2 is equal to 4. So I'll be having 100. Now over here it will say that it's even, so its value would be given by 1 plus f of 2 as per the formula. Its value would be given by 1 plus f of 1. Now f of 1 is actually 0, right? So the entire value I'll be getting over here is 1 plus 0 is this is 0. This would get a 1, right? 1 plus 1 is actually 2. So you'll be having 2 over here, and that's what you're gonna pass at the top. So over here also you can see that whenever you were having even values, you were adding a value 0, adding a value 1 to your answer. Otherwise you were adding nothing to the answer itself. Or in other terms, whenever you're so in other terms, the answer actually is the number of zeros that you will be having in the binary notation, right? I hope that makes sense. Also for g, so this was about f of x, right? What about g of x? So for g of x, I can give you the the similar logic, but easier thing to do is actually printing out the values and observing a pattern, right? So these are some of the values that I've printed for g of g of x. So at 1 its value is 1, that is known. At 2 its value is 3. At 3 its value is 2. Now look at 4, 5, 6, 7. So these have a value 7, 6, 5, 4. Then what about 8 to 15? So 8 to 15 have technically a value of 15, 14, 13, 12, right? Now about 16 to 32 would have the similar pattern. So basically at any power of 2 it has the maximum value, right? And then it starts decreasing until the time it actually gains another value of 2. So 2 to power 4 is actually 16. Now it's having a value 31 right now. Now this value would start decreasing till the time we have 2 to power 5, that is 32. So this decreases. So 2 to power 4 is 16. Now that starts decreasing, right? So 2 to the power 4 is 16. 16 has a value 31. Then the next number has 30, then 20 and 28. So this would happen till the time we reach to a value 2 to the power 5 minus 1. So 2 to the power 5 is 32, minus 1 is 31. 31 actually has the least value, that is 16. And then 2 to the power 5 has a value 63. And the similar trend would follow. So with that, what I can say is that for any power of 2, so if I am talking of a power of 2, right, technically it would have maximum number of zeros, because for a power of 2 only one bit is set. So it has maximum number of zeros also. And also, so this is basically f of x, and g of x is also maximized. Cool enough. So with that, a simple thing is that since I am given with the r and I want to maximize the number, so what I'll do is I'll take a log of it. So let's say my r was something like 7. I'll take a log base 2. I'll get the value as 2. Then I'll take a power of it. 2 to power 2 is basically 4. So in other terms, you can say that what I'm doing over here is that for whatever value I'm having, I'm taking the value that is less than or equal to it, and is a power of 2 also. So a power of 2 that is less than or equal to it is actually 4, right? Now the value of 4 would give me the maximum result. That's pretty obvious, right? Would give best result. So that is simple. Now why is this question tricky? It's not even that tricky, but yeah, that is pretty simple, right? So if firstly I'll just calculate. Okay, so cool. Yep, over here. So what I'm doing is I'm taking a logarithm of r, and then I'm taking a power of 2, or in other you can actually use a binary search for that, and or a lot of other things as well to calculate this. This is just a 2 line of code, so this looks pretty easy to me. So this the value of v now contains the least or the maximum possible v that is still the maximum possible value that is still less than r and is a power of 2, right? So if that value, so this is the tricky part. Now we also have to check if it's greater than or equal to L, because if the value of V is less than or less than L, then it's not something we can use, right? So if it's greater than or equal to L, then my answer simply is the number of zeros that I'm having, right, in the binary notation, plus whatever value is of g of v. Now there's a easier way to calculate g of v, but because of the constraint I actually wrote the function itself. So this is where I've written the function. So this is g and this is f. So this is a logarithmic function also, so I'm not worried about the constraints. Cool. So I'll be adding it. After that, I'll say that if that's not the case, then in that case, I'll start traversing from L to R, right? But then it's possible that the difference between L to R is too much, right? And then that would give me a TLE. So what can I do? Now simple observation over here is that when we are going from L to R, right, in each iteration I'll be decrementing the value of gx by 1, right? That's obvious. But why am I even doing it if my value is getting decremented? So I'm looking for a pattern. Let's say your value is getting decremented, but suddenly your value of fx actually spikes by, let's say, 2. So you were having a gx that was having a value, let's say, y. Then your gx plus 1 would be having a value y minus 1. Now let's say your fx had a value maybe 0, and your f of x plus 1 had a value 2. In that case, the value over here would be y, right? For value of x would be y. The value of x plus 1 would be actually y minus 1 plus 2. So you'll be having a value of y plus 1. However, the number of zeros is actually limited. So the number of zeros cannot exceed the length of the string, right? So length, cool. So now the number of zeros cannot exceed the length of the string, and this is something I can utilize over here. So I'll simply state that, okay, start traversing from L to R, right? But in case the difference between the current value and the difference and L itself, or the number of values you have already traversed, is greater than or equal to s dot size, or the length of the string itself, in that case I'm pretty sure that I'm not gonna get a better value, right? So in that case I can break it right over here, and in each iteration I'm just saving the value in my result variable, and at the end I'm printing it. Cool. So that was the solution. Let's look at the ranks actually. Not refreshed it. Let's see how many people did it. Okay, cool. So the rank is 38. Yeah, cool enough. For this minimum replacement, I'm not in a mood to do it, but I think this question is somewhat related to GCDs and BFS. I can be wrong because I didn't put much efforts into it, but I think it's somewhat related. So the problem is stating that you are given an array A consisting of n integers. In one operations, you can choose any two indices I and j. Subtract the minimum of AI and AJ from both AI and AJ, and note that the minimum of AI and AJ denotes. Cool. So that's gibberish. Determine whether you can make all the elements of the array equal to 0 in less than or equal to n operations, right? And then why I'm saying this is because if you're having two numbers AI and AJ, you can do some sort of operation so that one of them reduces to 0 in case their GCD is equal to 1, right? I guess that, or GCD is equal to 1, or GCD, like there was some kind of a logic. I'll have to write it down and I have to try some proofs for that. So I believe that it's somewhat related to mathematics and GCD. Maybe I'm wrong, but that's the intuition for this. But I'm not going to solve this anyway. Sorry for wasting your time on this. Cool. So that was it for the video. Let me know if you need any further help. More than willing to help you out always. Cool guys. Thanks a lot. Thanks a lot for watching this video as well. Bye bye.